We're going to be running through 5 additional examples for multi-step factoring in this video. The 5 examples that you see here, for the most part, these problems are going to involve pulling out a GCF factoring and then seeing if there's any additional factoring that we can do with those. So let's start with our first one. Got some pretty big coefficients going on here. 1294 and 180, so definitely, there's definitely a GCF. I could pull a 2 out for sure. I'm going to check and see if 12 goes into 94 and into 180. 12 does not go into 94. What about 6? Maybe 6 will go into 94. No, it doesn't. How about, we might try 3. 94 divided by 3, no. So it looks like 2 is the biggest thing we're going to be able to pull out here. So let's go ahead and factor out a 2. And I do notice that there are n's in each of these terms. The biggest number of n's we can factor out of each one would be a single n. So factoring that out, it's going to leave us with a 6n squared minus 94 divided by 2 is 47. And then plus 180 divided by 2 is 90. Looking in there to see if there's anything else we can pull out, and it looks like there's not. So we've got that 2n squared that's going to stay, but a trinomial left-hand side, I'm sorry, 2n that's going to stay. Trinomial left-hand side, we're going to try and factor that trinomial into a binomial. So I'm going to be working on the 6n squared minus 47n plus 90. Off to the side, I'm going to go ahead and write down my factors for 6n squared. That could be 6n times 1n, or 3n times 2n. 90, we got some options. 1 times 90, 2 times 45, 3 times 30, 4, no, 5 times 18, 6, 7, 8, 9 times 10. All right, so we've got several options going on here. This may take us a bit, but we'll work through it. Let's go ahead and try the 3n and the 2n to begin with. And I don't know, I'm going to go for the 9 and the 10. So 9 and 10, actually there's no point in checking that because the common factor 3 in the first one and 2 in the second one. Let me try flipping them and putting the 10 there and the 9 there. Let's see, 10 times 2n is 20n, and 9 times 3n is 27n, and can we combine those to get 47? Yeah, we definitely can. So, wow, we got lucky there. That's great. We're going to want, if we want a negative 47, we want the 20n and the negative, and the 27n to be both negative. So that means we're going to need minuses in both of those spots. Let me just double check that. I'm feeling a little too lucky there. 3n times 2n, 6n squared, that works. Negative 10 times negative 9 will give us the positive 90 that we're looking for. Negative 20, negative 27 should be it. All right, so I'm looking at those two factors to see if they factor any more, and they don't. So our final answer here is going to be the following. We've got 2n times the quantity 3n minus 10 times the quantity 2n minus 9. Next example. We've got a difference here, and it looks like it's not a difference of squares. However, we definitely have kind of GCF I feel like we can pull out here. 45 and 80 are both divisible by 5. Let's go ahead and pull a 5 out in front, and we'll see if there's anything else we can bring out once we do that. So 45 divided by 5 is 9. 80 divided by 5 is 16. And 9 and 16 do not have any other common factors. So, okay, so we pulled out the GCF. That's as big as we can get out in front there. 9n squared, 16n squared, those are both perfect squares. And we've got a subtraction in between them, so we can use a difference of squares here. We'll leave that 5 out in front and factor this down. We know that we're going to have one positive, one negative in there. We can get the 9m squared from 3m times 3m. 16n squared from 4n times 4n. Then we'll check all of our factors here, see if there's anything else we can pull out. And looking for GCFs, I'm not seeing any in either factor. Checking the second one to see if we can do a difference of squares again, but that's not going to happen either. So looks like That's going to be our final answer. All right, this one's got multiple variables and some big coefficients. Let's see what we can pull out of this guy. So 27, 36, and 12, those are all divisible by 3. 36 and 12 are both divisible by 6, but 27 is not. So I believe 3 is probably the biggest number we're going to get to come out of all 3 of these terms. And what else do we got? There is no variable that's present in all 3 of those, so we can't pull any variables out. So we're just going to have to pull the 3 out. That's fine. We'll go ahead and do that. We'll be left with a 9x cubed. No, I'm sorry. I'm wrong here. We do have x's in all 3 of these. Let's pull an x out in front. So that'll be 9x squared minus 36x. There's going to be a y still in there. Plus, oh boy. All right, slow her down here. We pull the 3x out in front. All right, divide by 3 and divide by x. That's going to be 9x squared minus divide by 3 is going to give us 12. Divide by x will give us an x, and we've got a y there. All right, and then divide by 3 will give us 4. Divide by x, the x's will cancel. We've still got a y squared there. My apologies for moving too fast and making mistakes. Okay, inside that parentheses, we want to check and see if we can factor anything. And I'm noticing this perfect square and a perfect square here, so I'm going to check. Let's just check and see if this works. If we use the square roots for these, so 9x squared we could get from 3x times 3x. 4y squared we could get from 2y times 2y. Let's just check and see if this will work. This will give us a 6xy and a 6xy. We're trying to get a negative 12xy. Yeah, and if both of these were negatives, that would work. So that looked kind of messy at first, but it was relatively easy to factor once we noticed those perfect squares. Not guaranteed to work, but oftentimes it will. So now I'm looking inside my factors to see if there's anything else we can pull out. I don't see anything. So my final answer, I'm going to write as 3x times the quantity 3x minus 2y. And rather than writing out twice, let's just square that and call it a day. All right, we got x to the 4th minus 27x. Definitely x's in both of those terms. So let's pull out an x. It's going to leave us x cubed minus 27. And that is a difference of cubes. So leaving the x out in front, let's go ahead and set ourselves up to factor that difference of cubes. Let's do our signs first. We started off with a negative. We'll do same, opposite, always positive. And let's put our building blocks in here. We know that x cubed is x times x times x, and 27 is 3 times 3 times 3. So we'll be using x's and 3's to fill in for the binomial. We're going to square both of those things at the front and back of the trinomial, and we're going to multiply those two things together, 3 and x together, for the middle term in our trinomial. So let's go ahead and write this out. Still got that x out in front, x minus 3. We got x squared plus 3x plus 9. And I'm looking to see if there's anything else we can factor out. No, no. And I know that anytime we have a difference or sum of cubes without a GCF to begin with, that nothing is going to ever factor out of that trinomial. So I could sit and try and do something with it, but I'm fairly confident that that's not going to factor any further. So that'll be our final answer. Okay, and here's our last one. We got some pretty big coefficients here as well. Definitely want to try and pull out a GCF. Let's see if we can get the biggest number out of 16, 64, 20, and 80. I know those are all divisible by 4. 16 and 64 and 80 are all divisible by 8, but 20 is not. So I think 4 is probably going to be the biggest we can get. Let's go ahead and pull out a 4 and see if there's anything left behind that we may have missed. So I can't pull out any x's because the 80 doesn't have an x in it. So we're just stuck pulling out a 4 at this point. Now, you may be thinking factoring by grouping, and we are going to do factoring by grouping, but you always want to try to pull out a GCF first, which is what we're doing now. So if we pull out a 4, we'll have a 4x cubed plus 16x squared plus 5x plus 20 here. And let's look at those coefficients, see if there's anything we missed. 4, 16, 5, and 20. No GCF there. Okay, so I am going to do factoring by grouping now. Just keep in mind that I do have a 4 out in front, and that'll be in my final answer as well. But let's go ahead and work with everything else. So leave this 4 here for right now. And let's examine our first two terms and see what we can pull out. It looks like we can pull out a 4 and an x squared from both of those terms. That will leave an x plus 4 behind in there. Second or last two terms, we're going to be able to pull out a 5. Yeah, 20 and 5, both of those will divide by 5. That'll be an x plus 4 as well. All right, excellent. I got an x plus 4 and an x plus 4 here. Those are common factor. Let's go ahead and factor that out in front. It's going to come right out in front, right where that 4 is. So the 4 was already out in front. We're bringing an x plus 4 also out in front. And what do we got left inside there? Just a 4x squared and a 5. Let's see if we can go any further with this. That's factored, that's factored. 4x squared plus 5. There's no GCF there, and there's no other special cases we can do. So there we go, and we're done.